Hi everyone, I'm Poonam. I work as a deep learning practitioner at Jarvislabs.ai. Thank you for joining me today. I'm going to talk about how to build an image classifier, a deep learning app, and share it on the web. And we are going to host our app on Jarvislabs.ai. So I'll just take you through what all I'm going to cover in today's talk. I'll be primarily talking about two things: how to prepare a machine learning pipeline to build an image classifier, and another thing is how to showcase it to the world, how you can demonstrate your application capabilities on the web user interface so that everybody can play around with it and see what your machine learning application is capable of. So for building the machine learning pipeline, I'll be using PyTorch framework, which is the deep learning framework, and I'll be building the dashboard using Gradio, and we'll be hosting our app or we'll be deploying our app on Jarvislabs.ai. So I'll just quickly show you what kind of app we are looking to build. So this is a dinosaur classifier app. My 6-year-old son loves all the things about dinosaurs, so he's very fascinated by them. So we were researching about their habitats and all of the types food specialities about dinosaurs, and I thought, why not build him a classifier which where he can upload an image, and my model can tell him or predict what kind of category that image belongs to. So this one is Stegosaurus here. So my model has predicted correctly that this is Stegosaurus. We can pass couple of different images, like this one is Parasaurolophus, so it did that one also correctly, and this is pterodactyl, that too it has got right. So I have taken around seven image categories or dinosaur categories, and I have downloaded models images for them, and my model will be predicting any newer image from among these categories, that which category that image belongs to. So this is a simple application I have built using PyTorch, and this beautiful dashboard you can see over here, it's accessible on web. So you can right now also go to dinoapp.jarvislabs.ai URL, and you'll be able to play around with. So we will be discussing how I have built this a complete machine learning pipeline, and how to build this beautiful dashboard using Gradio, and how we are able to deploy this, how we're going to deploy this app so that you can share it across your social media and showcase your machine learning model capabilities. Okay, let's go to Jarvislabs.ai website first. At Jarvislabs.ai, we provide modern NVIDIA GPUs, so you can rent the GPU and run your machine learning models and train the models quickly. And we have made it very easy to get started with the instance. So in few seconds, you will have your instance up and running, and you can immediately dive into your data pipeline and machine learning model pipeline without wasting much time in setting up things. So if you're new to the platform, please sign up over here. I already have an account, so I'll be signing into my account. We have all the popular frameworks that are available used by machine learning practitioners. So we have PyTorch, FastAI, TensorFlow, and also we have something called BYOC, bring in your own container. So you can have any Docker image that you have set up for your work, and you can just get up and running your GPU instance using that container, so that you don't need to do any installations. You have that option available as well. And we have all the modern NVIDIA GPUs like RTX 5000, 6000, A5000, A6000, and A100 cards. We also have CPU option. So for this particular project, I'm going to use FastAI library, which is a wrapper on PyTorch framework. And since this is a small toy data set, RTX 5000 GPU will be sufficient for the training. So I'm going to launch that one, and I'll be needing just one GPU, but you can simultaneously launch up to 8 GPUs and faster your machine learning training process. Also, if your work is kind of okay to be interrupted, like you're learning about machine learning or deep learning, you're doing some hobby projects or any kind of work that can be interrupted at any point of time, and you can continue further, you can make use of spot instances, and they come at much significantly lower prices, and you can launch the instance in few seconds. Your instance will be ready, and you can straightforward go to Jupyter Lab. I already have RTX 5000 ready, and I'm gonna just click on play button, which will take me to my Jupyter Lab. So I have here two notebooks here ready, one for training my model and one for doing inference, and also building the dashboard for grading. The code is taken from Jeremy Howard's kernel. He's from FastAI. He is built a simple machine learning model which identifies bird from forest images. So he's classifying bird and forest images. So the code is more or less similar to his with very slight modifications. So for the machine learning model pipeline, we need to gather data. You can also use a machine learning repository datasets or Kaggle datasets if you don't want to do it from scratch. But you can gather data. I'm going to show you how you can download images from DuckDuckGo based on whatever categories you need to search for, and how you're going to create a data pipeline, and also how you're going to train the model, and how you're going to do the predictions at the last. So for that, we'll be using PyTorch framework. So let's get started with the first part of our talk. We are going to import all the FastAI library. FastAI library is like a wrapper on PyTorch, so it has all good things from PyTorch, and on top of that, they have created beautiful functions for making your life much easier. So this search images function is gonna search around 200 images of each category. I have taken 7 categories of dinosaurs, so I have given here search terms. So based on that search term, I'll get around 200 images of each category, and they'll be stored parent folder called dinosaurs. This is my path where my images are stored. There are around 1400 images of 200 each from 7 categories, and we might get some faulty images which may not be in proper format, so we need to remove those images. So there's a function called verify images which does that part for us, and it removes the images for us. So that's the downloading part we have completed. Next, we have to prepare the data pipeline. For data pipeline, we primarily need to tell how input and outputs are going to be, and what kind of splitting you need to do for training and validation set. Validation set is very important to have a validation set kept aside before starting to train your model, so that we can check our accuracy of our trained model later on validation set. So FastAI provides a data block module which takes care of building a data pipeline for us, and we are going to tell it what kind of data we have. So we have here image and category image data set, so we're going to tell we have images and some categories for that, and then we're going to specify how the FastAI will take care of getting those image files path. So for that, you need to have proper folder structure. So this is my parent folder dinosaurs, that's what I have given in the path, and inside the dinosaurs I have separate directories for each category, and inside the directories there are images for that particular category. And we're going to tell here FastAI what kind of split you want. I need to keep aside 20% of my data set for validation, and we're going to tell how we are going to get the label for the image. For the particular image, it will just take the parent folder name, and we're gonna do a lot of transformations to make a machine learning model better. But right now I'm just using resize here, so I'm gonna tell it a block that resize my images for 256 to 256 size. So show batch shows what kind of data we have. We have these kind of images that we have downloaded from DuckDuckGo. So on these images we're going to train a model. Next part is training the model. For that, we are using Vision Learner module from FastAI, and we have taken this state-of-the-art ImageNet model. It's a ResNext version. It's SE ResNext. So we are gonna train our data using that model. So for me, it took around 2 minutes to train this model for 15 epochs on RTX 5000. If you have much more data and you're doing advanced models from PyTorch, you can also use TensorFlow, by the way. You can use A100 GPU instance, which will make your training much more faster, and you can save on time. So I have already trained my model and saved the weights here. So I'm going to just load my weights. Once I load my weight, the third part is prediction part. How am I going to predict the image? So I have given a small prediction function here, find a dinosaur. So I'm gonna pass that function. Next part is we are gonna define a prediction function where we're going to learn how to predict the image, new image, what category it belongs to. So this find dinosaur function does that for us. So I have passed this image. This is a Brachiosaurus. I've asked my model what kind of dinosaur is that. So it has returned me Brachiosaurus correctly. So that's it. We have built a beautiful machine learning application which predicts the name of the dinosaur given an image. Okay, it was so simple and straightforward using PyTorch and FastAI, and we are going to do next part now, much more interesting part, the second part, where we are going to showcase our application to the world. So how can we do that? I'm using Gradio. It's a beautiful app which has web interface capabilities. So it has we can use that to demonstrate our machine learning application. So Gradio creates beautiful web interface. So this application just now I showed you, this web interface is using Gradio at the back end. I'm going to show you how you can build this dashboard, these kind of dashboard using Gradio. So let's go back to our code. This is the inference notebook. Don't forget to install Gradio on the instance. I've already installed, and we are gonna specify the path for a directory where the data resides, and we're gonna define the data loaders. So this is the images that we have, and we're gonna define the loader and load our weights. We already have saved weights in the previous notebook here. So we're going to load the weights, and we are going to define the prediction function that we had. So till this everything was same. Now the important part is how to build this dashboard using Gradio. So Gradio asks for a couple of parameters. Mainly it needs a function to predict the image. It's mostly machine learning prediction function, which will it needs a function which will be used to predict the any images. You can also upload images. So if user uploads any image, they will be predicting that image using that function. You can predict the category of that image and how the inputs are going to come and what are the labels for the output. So I've taken here 3 top classes. There are actually 7 categories, but I'll be showing only 3 top categories that it is predicting. So majorly this one is the correct category. So these are the examples. So we can also load some photos here in the dashboard itself. So users don't need to go and download images themselves and upload it here. They can quickly just run around these images and predict what kind of images they are. So these images I've kept in the examples directory. So here is my example directory with a couple of images from each category, and article is the one kind of my observations about this project. So I'm going to talk about what kind of data set I have written, this small block kind of thing here, that how I have gathered my data, what kind of categories I'm using. So when the users are uploading the images, they have to upload something from these categories to get the correct results, and what kind of data block code I have, what kind of augmentations I've used, what does my training look like, what does my loss look like, and what are observations I have noticed when I was training my model and getting the predictions out of it. So these are the example directory. First of all, these are the interface options. I'll be telling Gradio that please have this as my title of my dashboard and little description about my project, how I have done it based using what I have been using FastAI and dashboard by Gradio, like that. Then this example directory path. This is the article MD file. I have written it into MD file here, all the information. So this is setting up the Gradio. Now the most important, the last part of the talk is how you can host your model on Jarvislabs.ai. We need to tell Jarvislabs that please launch the Gradio dashboard on this particular port. So we are specifying 6006 as a port and launch it on this server. So once you launch it here, you will be able to access this dashboard. For accessing, you need to go here to your running instance, right click on this running instance card and go to get URLs and choose API endpoint. When you choose that, you will find your app running here, and you can share this URL with the world, okay, across your social media platform. So my app is running here. You can right now also go to this URL and play around with this app. It was very simple and easy. You can create something like this, and let me know how it goes. I would love to see what all you can build. The notebooks are available in this GitHub repository, and the demo page is dino app.jarvislabs.ai. You can play around this app and let me know how it goes. I hope you liked the talk, and I would like to thank Women in Data Science platform for giving me this opportunity to talk here. Have a great day. Thank you.